So whenever you see a single fraction equal to a single fraction, we've just looked at some easier ones. We have a little bit more going on here. You take this times this equal to this times this. So in this particular one, I would have negative 10 times x minus 5, one of my diagonals, set equal to negative 220 times x, or excuse me, negative 20 times x. Next, I want to distribute the negative 10 through. So if I distribute, I'm going to have negative 10 times x, and that'll give me negative 10x, and negative 10 times negative 5 is 50. I'll bring down the equal sign, bring down the negative 20x. Now we're going to move letters to one side, numbers to the other. So I'm going to take these x's and move it over here. To get rid of minus 10x, I'll add 10x. Okay, and then we have 50 left over. Negative 20x plus 10x is negative 10x. Divide both sides by negative 10. And then finally, 50 divided by negative 10 is negative 5. Now the one thing that you may not realize is there are certain times where you have to check your answer, and there are some times where it's optional. Like if you did the math correctly, and then it's optional because as long as you did your steps correctly, you've got it. But in equations that have an x or a variable in the denominator of the fraction, if the original equation has an x underneath an even root, then you've got to check the answer because you're worried when the original equation has an x in the denominator that if you substitute this back into the original, you can't divide by 0. So you don't need to do a complete check to simplify, but if I put negative 5 back in the original, the first denominator becomes negative 5 minus 5, which is negative 10, that's okay. Put a negative 5 into this denominator and it's negative 5, that's okay. So negative 5 is my answer. But if we would have solved and got positive 5, and you substitute it back in here, 5 minus 5 in that denominator is 0, and you can't divide by 0, so you'd throw this out and it would be no solution. So every time you get to an equation where you see a variable in the denominator, you need to remember I must check the answer because there's a chance you throw it out and there's no solution. Okay, so just one more quick example of the same thing. Negative 8 times negative 2. Whoops. Negative 8 times negative 2. Set equal to 10 times x plus 7. Distribute the negative 8 and the 10 through. If you distribute the negative 8 and the 10 through, I get negative 8x plus 16 equal to, and then 10 times x is 10x, and 10 times 7 is 70. Letters on one side, numbers on the other. So I'm going to move the x's to the left by subtracting 10x. I'm going to move the 16 to the right by subtracting 16. And so left here on the left-hand side, negative 8x's and negative 10x's is negative 18x. Bring down my equal sign. And then 70 minus 16 is 54. Okay, now get rid of multiply by negative 18 by dividing by negative 18. And these guys cancel, so I have x by itself, and then this fraction simplifies. 54 divided by negative 18 is negative 3. Okay, so one more time. Every single time the original equation has a variable in the denominator, you have to check. So if I check this negative 3 going back into the original, the first denominator becomes negative 3 plus 7, and the other denominator is negative 3 minus 2. Neither one of those equals 0, so we're okay. But if this number, when you plug it in, makes those either one of the denominators equal to 0, you'd throw out the answer because you can't divide by 0. Okay. And then this is just a reminder, like, why does this work? why can I set this times this equal to this times this? Our other strategy is, when you see an equation with fractions, you immediately multiply both sides by the denominators. So my denominators are x minus 5 and x. So if I multiply the left side by x and x minus 5 and the right side by x and x minus 5, the x minus 5's cancel, and I'm left with negative 20 times x. Multiplying the right by both of the denominators, the x cancels, and I get negative 10 times x minus 5. So notice what that really amounts to is that was negative 20 times x is equal to negative 10 times x minus 5. So setting this times this equal to this times this is a shortcut to multiplying both sides by the denominators when you see a fraction.